Thanks to the PBCRC for inviting me to present today on behalf of our project team. Certainly delighted to have come into the project right at the end, but having access to some of the great and interesting talks you guys are all doing research on has really opened our eyes up into what other areas are being studied, and it's certainly something we never would have had the chance to benefit from. So thank you. Of the pests and diseases already in Australia, our greatest biosecurity threat to grapevines is grape phylloxera. The tiny insect destroys vines by feeding on its roots, and vines can die within about 5 to 6 years depending on the strain. And if you do have a phylloxera-infested vineyard, really your only opportunity then is to replant vines using resistant or tolerant rootstock, because there's no treatment for phylloxera. So the Australian wine industry contributes around about $40.2 billion in gross output to the Australian economy each year. And we've got some of the oldest grapevines in the world at around 175 years. So it's certainly something worth protecting. And with estimates that we've got about 70% of grapevines grown on owned roots, it's certainly, and those being susceptible to phylloxera attack, it's certainly continued work on improving phylloxera detection methods is vital for us in our industry. So the challenge that we see is using a suitable surveillance strategy for sampling to find this 1 millimetre insect in a vineyard block or in a larger scale such as a wine region or even a state, and then to use a detection method to give us the greatest chance of detecting phylloxera at that sampling point if it happens to be there. So our industry is hugely connected, and I'm sure that's probably a commonality between a lot of agricultural industries. So many growers share the same contractors to undertake activities such as pruning or spraying or harvesting, and a finite number of wineries send around their staff around vintage time to look at, hundreds of blocks in a day, and all in the lead up of vintage. And so the spread of pests and diseases between our vineyards is therefore highly likely if no mitigation methods are put in place. The problem we face with phylloxera is that we're unlikely to detect incursions early to stop the spread, because symptoms are really quite similar to many other grapevine issues, and as we've heard already, vine death can actually take years. So it's sort of not going to be an overnight keel over of a vine that you're going to notice that you've actually got a problem. And we think really that our only chance of early detection is going to be in instances where we have non-compliance. So therefore we need accurate detection methods for phylloxera to delineate with certainty where phylloxera is and is not as part of implementing strong prevention activities. So the importance of this particular project was to develop another detection method for phylloxera that was no less accurate than the current endorsed visual root inspection method, but which would not require field expertise, so that any grower could go into the field and follow a protocol to collect a soil sample which would then be analysed in a laboratory. So this detection method really involved 2 steps. So it was to test a range of parameters to optimise an in-field sampling protocol that was simple to follow, didn't really require any fancy equipment, yielded a sample which was accurate enough to allow detection of phylloxera, and was cost effective as well. And then accompanying this was to validate the laboratory qPCR protocol, and also to see whether there could be any other value adds that could be added at the laboratory, so whether we could test for other things such as nematodes, etc., to be offered at the same time as when the phylloxera was being processed, or the phylloxera result was being processed. So various different trials were undertaken to validate a whole lot of attributes. So this was things like where to take the sample in the vineyard, at what time of the year to take it, what conditions we needed to transport the sample to the laboratory to minimise degradation of the DNA. And then we also compared the DNA method with emergence traps, which are often used by scientists, and also the currently endorsed visual root inspection method, and to look for accuracy of detection across a lot of different trials using those 3 methods. So the time of the year we did find important, and that impacted significantly on phylloxera abundance. So that was highest in autumn and lowest in spring and summer. But the frequency of detection wasn't impacted by the time of the year. So with the one really good thing about the DNA method is that it can actually be conducted all year round, and that is unlike our other 2 methods. So the position and depth of the soil was looked at in terms of where to take the sample. So we found that the frequency of detection was highest when the sample was taken closest to the vine trunk rather than under the dripper. And so our protocol is to take that soil core within 10 centimetres of the vine trunk. Now, we also looked at presence of vine root in the sample, and this was really to have an added quality control check in the lab. Because we know phylloxera's affinity with vine roots, we could say that if you had low vine root DNA in the sample, it really lessens your chance of a positive DNA, of positive phylloxera result. So that's just a bit of a quality control check for samples coming into the lab. Sampling density, as I mentioned before, was certainly something we looked at in a number of trials, and we did find that in two of four of our trials where infestation levels were really low, that by doubling the sampling density, it did actually change the phylloxera status of the vineyard. So it might have gone from nil to actually phylloxera detected by doubling the sampling number. And we did actually look at tripling sampling numbers as well, but in those particular blocks, it didn't change the result from the double. Compositing of soil samples is certainly something we looked at as well, particularly from a cost basis. So being able to, by pooling a number of soil samples together, that was something we could look at to reduce the overall cost of what it would take for someone to sample a block. And what we've recommended is for 5 soil cores to be sampled together, or to be pulled together, as one sample. We do need to be a little bit careful with this, though, that if you do get one positive core and, say, 5 negative cores, you do need to make sure that that mixing of the positive and negative doesn't actually, reduce your potential of actually being able to pick up that positive. So what we're saying is that 5 cores mixed together is probably going to be at an okay level to still be able to detect that positive, whereas if you sort of composited maybe 10 samples together, you may lose that potential of picking up the positive. Temperature and duration of soil sample storage was something we also looked at in terms of getting the samples from the vineyard to the lab. And samples don't need to be kept cold. We need to transport them at around about 10 to 20 degrees, but they do need to reach the lab within about 48 hours of collection, and then to be dried to preserve the DNA within about 24 to 48 hours. We did compare the sort of accuracy and limitations of the 3 methods, and really these did vary quite a lot in terms of sampling speed within the vineyard, and also the turnaround time of getting a result from the 3 methods, and also the cost. And other, practical limitations were also found. So when the soil was too dry, obviously it's really hard to dig. So the visual root inspection method couldn't be used, and to a lesser extent the DNA method as well. The emergence traps were best in summer and ineffective in winter, really when the phylloxera bury themselves too low at depth. And the DNA method was found to be as accurate as the emergence trap method and more accurate than the visual root inspection method overall. We did also have a look at the sensitivity of the qPCR method for phylloxera detection in the lab, and that was found to be able to detect phylloxera down to 1.5 to 2 phylloxera equivalents per 200 grams of soil. So in terms of who's going to use the DNA method, we really think there's 2 primary targets. So you're looking at the regulators, and then you're also looking at grape growers. So in terms of the regulators, that's really state government biosecurity departments that we're aiming this at. That also includes Vine Health Australia, the organisation I work for. And really for us, it's all about establishment and maintenance of phylloxera management zones. And then if you look at the other primary target being the grape growers, so we've got around 6,000 grape growers nationally who could potentially use this. And really for them, it's about a proactive risk management tool and the effectiveness of their farm gate hygiene practices. And for them also, if there is a value add of being able to look at, say, nematode results as well, it's about knowing what else is out there in their vineyards. And then for me, secondary supply chain impacts as well need to be considered as part of the method. So there's a lot of other groups who obviously interact with vineyards. Obviously wineries, nurseries, contractors, suppliers, etc., whose activities really are impacted by the phylloxera management zones, which will result from the use of the DNA method or other methods to verify where phylloxera is and is not. So Yeah, so those are listed there. In terms of using the DNA method from a block basis, really the standard DNA methods will be delivered to end users in the form of a field sampling protocol that I was talking about, and that's going to contain components like how to take the sample, sample handling instructions, and also how to send it between different phylloxera management zones to the lab, which at the moment is the SARDI Molecular Diagnostic Centre in Adelaide. The surveillance at the moment currently works on a grid basis, as Michael said, where you collect one sample from every fifth panel and every third row. So that gives you about 40 cores per hectare, and if you composite up 5 cores into a sample, that gives you about 8 cores per hectare. And then we sample weak vines separately. So once the soil samples reach the lab, as I said, to preserve the DNA, the soil samples need to be dried, and then they need to be analysed, obviously using the qPCR. And the SARDI Molecular Diagnostic Centre has the capacity at the moment to sample around about 500 samples a day, so it's high throughput. And I guess the DNA, from a block basis anyway, the DNA detection method's expected to facilitate preemptive checks of vine health for proactive management of vineyards for phylloxera, and really buy growers time to make informed decisions about, say, replanting to rootstocks. And then also for the regulators to use in response to potential incursions. One current downfall, though, we do have of the DNA method at the moment is that it's not able to determine phylloxera strain. So in cases that is required, we actually need to then go back to a block and use one of the other methods to actually catch the insect, and then obviously verify that for formal identification and then for strain typing. So on a landscape level, at the moment, each of those 3 detection methods that we looked at do have a strong chance of detecting phylloxera if the infected vines are those actually sampled in a surveillance plan. However, with the sampling, with the standard grid sampling method, we really only got about 2% of vines in a hectare that are going to actually be sampled. So if an infestation really hasn't spread enough to be a clump of vines, a detection really could be, only really by chance. So, and also if there's really no visibly weak vines to target in a landscape or a block, using that apart from that standard grid, that really makes early detection anyway, really difficult. So at a landscape level, we think we need a greater focus on where to sample to inform our surveillance strategy. So to increase the likelihood of sampling a vine that is infested, we think we need more information and integration of multiple surveillance and detection methods. So really it's all about a numbers game. So what we're proposing could be something from a surveillance strategy to look at would be looking at stratifying the sampling area based on a risk-based approach, to sample at a higher density in areas obviously more likely to be infested, and in conjunction to employ technology such as multispectral imagery to help identify weak vines which may have phylloxera but are not necessarily yet visually weak for us to see to the eye. And I guess underpinning that is really about improving our knowledge through basic science research on how phylloxera moves and survives, and this is also going to help us in our risk-based approach to surveillance. So really quickly, this is Andy Clark from Yering Station, who is one of our end users, and just I think gives a really good summary of the potential for the DNA method. So Andy says growers will have the capability of collecting samples themselves without needing an expert in the field, and with a method that can be used year-round. So a lot of sampling can be done to give growers ownership of their destiny, and I think that really sums it up well. So in terms of next steps, for endorsement for us towards commercialisation, there's a couple of things. So we need to incorporate the DNA method into the National Diagnostic Protocol for phylloxera, which is being done at the moment through Barpol, and that's being looked at by some overseas researchers for validation. We're then also going to integrate the DNA method into the National Phylloxera Management Protocol, so that will allow us to gain industry endorsement. And then once we've actually got, obviously, commercialisation, we will then go through a communications plan to facilitate end user training of the protocol. And so in terms of, I guess, for us, future for DNA method, obviously, as I said before, the one problem we do have is that we can't strain type. So what we'd be looking at would obviously to be try to do that with the DNA method if we could. Looking at in-field analysis is always, I guess, everybody wants that to make it really fast identification in the field. And really what we do need is more research on where to sample, and that's really what would be the biggest benefit. So, we really see the project has delivered a significant advancement in the ability of industry and regulators to detect phylloxera and therefore manage the impact of this devastating impact of insect on vines. So I'd just like to finish by saying thank you to the PBCRC for funding the project, thank you to the growers who availed their vineyards for us to do the trials on, and thank you to current and past project team members for their valuable input.